Today we're going to talk about is oblique or slant asymptotes. So, if we want to figure out the end behavior of the function x squared plus 3x plus 5 over x minus 2. So we could think about a couple of things, but really a rational function is division. So we could think, well, the quotient is degree 1. That probably means that it should behave like a linear, right? Because if the quotient's degree 1, it should behave like a linear. But the question is, which linear, right? So what's the slope? What's the y-intercept of that linear that it behaves like? And what's it all going to look like? So, so far we have this. And you can think to yourself, well, it's a good thing that I know how to divide polynomials. So we carry out our long division. And it looks something like this. So we know that x squared plus 3x plus 5 divided by x minus 2 is x minus 5. And it's got a remainder 15. So that means that we can write the function as x minus 5 plus the remainder over the divisor. Right? That's our division statement. Okay? So if we plug in a big value of x, which is what end behavior means, so x is infinity, positive or negative, that whole thing there goes to 0, or really close to it, right? Because we have 15 divided by a huge number, which is going to be 0. So really, that means that my function f of x behaves like x minus 5. So it behaves like x minus 5 for big values of x. What does that mean? Well, we have f of x is that function, or we could write it like this, which is what we found out. So let's graph x minus 5. So there's x minus 5. And what we know is as x goes to infinity, our function is going to get close to x minus 5. But really, we need to take into account that there's a vertical asymptote as well. And we should always look at what does the function behave like around that vertical asymptote. Well, as x goes to 2 from the right, we can plug in like 2.01, and we get a positive number.
Power and best friend, please come down to the main office. Power and best friend, please come down to the main office. Thank you.
And as x approaches 2 from the left, we can plug in 1.99, and we get a negative number. So that means we have these behaviors. Now, if we know that as the function moves to the right, it's going to approach this line right here, the only thing that could happen is this. So the only thing that could have happened is as it goes to the right, it approaches this asymptote. And here, as it goes to the left, it approaches that asymptote. So, that's it for now. We'll talk a lot more about this tomorrow. Well, that's it for now.